Let's look at properties of polynomials. For example, let's state the left and right behavior, find the maximum number of zeros and the maximum number of local extrema for this polynomial here. F of x is equal to 6x to the fourth minus 7x cubed plus 4x squared plus 6x. Let's begin by looking at the left and right behavior, or the end behavior of this polynomial. Now, a polynomial function is one of the following form. F of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a1x plus a0. N here is called the degree of the polynomial, and a sub n is called the leading coefficient, which we are assuming is non-zero. Now, the graph of any polynomial function f will eventually rise or fall without bound, and to determine what happens, we look at this degree and the leading coefficient. Namely, we have the following four cases. If n is odd and a sub n is greater than 0, then the graph of f will eventually fall to the left and rise to the right, as this figure shows here. And this should make sense to you, because as x goes to positive infinity or negative infinity, the leading term a sub n x to the n will dominate all the other terms combined. So if n is odd and x goes to infinity, then x to the n will also go to infinity. And because a sub n is greater than 0, then the graph will eventually rise without bound as x goes to infinity. And as x goes to negative infinity, then x to the n will also go to negative infinity. And because a sub n is positive, then the graph will eventually fall without bound as x goes to negative infinity. And applying the same type of logic when n is odd and a sub n is less than 0, we get that the graph of f will eventually rise to the left and fall to the right. However, when n is even though and a sub n is greater than 0, then the graph of f will eventually rise to the left and rise to the right. But when n is even and a sub n is negative, then the graph of f will eventually fall to the left as well as fall to the right. So looking at our polynomial here, we see that the degree is 4 and that the leading coefficient is 6. That is, n is equal to 4, which is even, and a sub n is equal to 6, which is greater than 0. So we're in this case here. We're in case 3. Which means that we can write our answer up here that the graph of f eventually rises to the left and rises to the right. Now it still remains to find the maximum number of zeros, or x-intercepts, and the maximum number of local extrema. And again, the degree here governs that. We have the following two cases. That a polynomial of degree n with real coefficients has at most n real zeros, and at most n minus 1 local extrema or turning points. So for our polynomial, we have n is equal to 4, which means coming back up here, the maximum number of zeros then would be n, or 4, and the maximum number of local extrema would be 4 minus 1, or 3. All right, let's look at one more. Let's state the left and right behavior of this polynomial here, as well as find the maximum number of zeros and the maximum number of local extrema. All right, let's start again with the left and right behavior. Which of these four cases are we in? Well, what is the degree and the leading coefficient of our polynomial here? If we multiplied it all out, we'd have f of x is equal to negative 2x cubed plus a bunch of other stuff. Because when we square this out, we're going to have a degree 2 polynomial, which then we're multiplying by a degree 1 polynomial, which would give us a degree 3 polynomial with leading coefficient negative 2, which means n is equal to 3, which is odd, and a sub n is negative 2, which is negative. Which means we're over here in case 2, aren't we? Therefore, the graph of f eventually rises to the left and falls to the right. And now let's state the maximum number of zeros as well as the maximum number of local extrema. Recall from our last example that a polynomial of degree n with real coefficients has at most n real zeros and at most n minus 1 local extrema. So here n is 3, which means coming back up here, the maximum number of zeros then would be 3. And the maximum number of local extrema would be 3 minus 1 or 2. And this is how we work with some properties of polynomials. Thank you, and we'll see you next time.